All right, so today we're going to do the first part one of the solving trig equations, which off your packet will get us from problems 1 through problem 14. You will need your unit circle, so please make sure that you do have your unit circle with you. So if we go back to just the basic graph of sine x, okay, sine x looks like this. So if you go back and we graph, sorry, I put that point in the wrong place. If you go back and to your graphing notes where we just graphed sine x, that's what the sine wave would look like. Just a basic sine x. No shifts, no movements, no stretching, no shrinking. So on this particular example over here to the right, it says give the solution to the equation sine x equals to 1/2 on the interval. Okay, so my y value is 1/2. So I'm going to go here because that's where y is 1/2. So my x value is going to be here and here. Those are the two places where, when you look at this graph, the sine x value has a y value of 1/2. So that would be at pi over 6 and at 5 pi over 6. Now, the difference between this example and this example is it says give the solutions for all answers. So when it does not limit you to one trip around your unit circle, what we're going to do is we are going to list both of these answers from the previous problem, but we're also going to add 2n pi, because that means if I'm at the unit circle and I am at pi over 6, if I go around 360 degrees, I still end up here. So I can go as many times as I want in either direction, positive or negative rotations. So I'll do the same thing. So when you are solving equations, you have to pay attention to the interval that they give you. This interval, 0 to 2 pi, is restricting you to one trip around the circle. And this interval, negative infinity to positive infinity, is for all solutions with multiple, infinitely many trips around the circle. Okay. Now, the two bullets in the box below the graph, a trig function or a trig equation can have one solution, no solution, or several solutions depending on the defined interval. To solve a trig equation, isolate the trig functions. So the first few examples, that's exactly what we're going to do. We're going to isolate the trig functions. We're going to consider the intervals that they give us, and then we are going to come up with our final answers. So in the first example, I want to isolate the trig function. So I want to isolate cosine. So what I'm going to do is I'm going to subtract 5 cosine x from both sides. That leaves me square root of 2 equals to negative 2 cosine x. And then I'm going to divide those sides by negative 2. Now, on your unit circle, you will see several angles that have the x or y coordinate as a square root of 2 over square root of 2 over 2. So cosine, remember we talked about this last week. Cosine is always the x value. Sine is always the y value when you're on your unit circle. Now, when I go to my unit circle, I'm looking for angles that have negative cosine values. Cosine is positive in first, it's positive in fourth, which means cosine is negative in the second and the third quadrant. So I go and I grab the two angles in the second and the third quadrant where cosine is negative square root of 2 over 2. That would be 3 pi over 4 from the second quadrant, and from the third quadrant, that would be 5 pi over 4. Now, I look at my interval. I do have unlimited rotations around that circle, so I have to add the 2 pi n, or 2n pi for both of those answers. When you have an unlimited interval, you have to add the unlimited amount of rotations. So for our second example, I want to isolate tangent theta. So I'm going to add 3 tangent theta to both sides. That gives me 6 tangent theta on the front. I'm also going to subtract 2 square roots of 3 from both sides. So that would cancel it from the left and move it to the right and give me 6 square roots of 3. Divide both sides by 6 to cancel the 6 in front of the tangent. And I have tangent equaling to positive square root of 3. Now, on my unit circle, there are 2 places where tangent is positive, first and third. Okay, so I need to find the angle in first and third quadrant that has a tangent value of radical 3. Well, that would be pi over 3 in the first quadrant, and that would be, that would be 4 pi over 3 out of the third quadrant. Now, tangent is special because if you graph pi over 3, that's 60 degrees, and then you graph 4 pi over 3, you only have to travel 180 degrees to get from one angle to the next, and then you keep rotating. So when you have a tangent, we're going to add pi in because we don't have a full rotation. We go from 60 to 240, back to 60, back to 240. So every 180 degrees, we terminate at the same place the original angle was. So we do not need that value. This is the only value. So tangent is special. Cotangent will also be special. Secant, cosecant, sine, cosine, they all have a 2 pi n rotation. Tangent does not. Cotangent does not. So for number 3, we want to isolate cosecant. So I'm going to multiply both sides by 4, and that gives me negative 4. I'm going to add 6. So I have cosecant alpha equals to 2. Now, I'm not very familiar with cosecant, but I can rewrite this as sine of alpha equals to 1/2 because they are reciprocals of each other. So I take this value and I flip it upside down, and that gives me the sine equivalent. Now, sine is positive in first and second quadrant. I am on an unlimited rotation, so I am going to have to add the 2 pi n to my final answers. So here, sine is 1/2 at 30 degrees. So alpha is equal to pi over 6 plus 2n pi. And in the second quadrant, it's at 150, where sine is 1/2. And that would be at 5 pi over 6 plus 2n pi. So you have to go, remember, sine of any angle is the y-coordinate. So you're looking for positive 1/2 as a y-coordinate in quadrant 1 and quadrant 2. In number 4, we're going to isolate secant. So that would give me 6 secant y when I subtracted the 1 from that side. I'm going to divide by 6. So secant of y gives me negative square root of 3 over, negative 2 square roots of 3 over 3. Well, I can change that to cosine of y by flipping this fraction. So that would be 3 over square root of, or 3 over negative 2 square roots of 3. I have to rationalize. So that would be 3 square roots of 3 over 6. And that ends up being the square root of 3 over 2. But it is negative because you have a negative divided by a positive. So now I'm going to go to my unit circle. I'm going to identify the two quadrants that has a cosine that is negative, which is second and third. We are on an unlimited rotation. So y is going to equal to the second quadrant angle that has a cosine value that's negative 3 over 2 is 5 pi over 6. We're going to add the unlimited rotations to it. My third quadrant angle that has a cosine value that is negative 3 over 2. If you look in your third quadrant, that should be 7 pi over 6, 210 degrees, plus 2n pi. Okay, so we've done some with the unlimited rotations. Now we have some limited or defined intervals. So all of our answers have to fall on our unit circle between these two angle measures. So in the first one, we're going to isolate tangent. So that would be 2 tangent A equals to negative 2. Divide both sides by 2. And that gives you negative 1. So I'm going to go to my unit circle. I'm going to identify the two quadrants that I need to look in from 0 to 2 pi. Tangent is negative in second and fourth. So I need to identify the angle where tangent A is negative 1. That would be at your 45 degree angles because they both have square root of 2 over 2 as their x and y value. And remember, all tangent ratios are y over x. So we have to find where tangent is 1. Tangent is always 1 or negative 1 at your 45 degree angles. So the quadrant 2 angle would be 3 pi over 4. We do not need to add the unlimited rotations because we do have a restricted domain. And my fourth quadrant 45 degree angle would be 7 pi over 4. These are the two angles in second and fourth quadrant that have x and y that are the same because when you divide something by itself, it becomes a 1. So that's why I chose these two angles out of quadrant 2 and quadrant 4. Tangent is negative in both of those quadrants. In number 6, same thing. I'm going to isolate the sine squared u. So the first thing I'm going to do is subtract 8. So that's 4 sine squared u equals to 3. Divide both sides by 4. I get sine squared u equals to 3 over 4. I'm going to take the square root of that. Remember, when you use the square root property, you get a plus minus square root of 3 over 2. The denominator is a 4, and you can take the square root of the denominator, but you cannot take the square root of the numerator. So I need in the quadrant that represents pi to 3 pi over 2. Here is pi. Here is 3 pi over 2. I need one answer. I cannot give any answers in the other three quadrants because I am restricted to just this quadrant. So I'm going to find the spot where, or the angle in quadrant 3 that has either a positive or negative square root of 3 over 2 as its y value, because sine is always y when it comes to the coordinates on your unit circle. So my angle is going to be 4 pi over 3. That is a quadrant 3 angle where the sine value is either positive or negative square root of 3 over 2. I am restricted to answers in quadrant 3 only. number 7, we could do number 7 the same way, or we can use some factoring techniques. So since all of the problems on this page require factoring, that is what we're going to do. Because once you get something factored, then you can set the factors equal to 0 and you can solve each one of the smaller equations. So this is a difference of squares. This is 4 cosine squared minus 1. So I am going to factor that into 2 cosine x plus 1 and 2 cosine x minus 1. This is a difference of squares. It is no different than 4x squared minus 1. The only difference is it's not just x squared, it's a cosine x squared. So now I'm going to take each factor, solve them separately. I am on a restricted interval, so I have limited answers. So 2 cosine x equals to negative 1. Cosine x equals to negative 1/2. Second factor, I get 2 cosine x equals to 1, and cosine x equals to positive 1/2. So for the first one, cosine is negative in second and third quadrant. So I'm going to go to the second and the third quadrant, and I am going to pull the angles out of the second and the third quadrant where cosine x is negative 1/2. That would be 2 pi over 3 from second quadrant and 4 pi over 3 from third quadrant. Now, on the other side, I have cosine is positive 1/2. Cosine is positive in the first and the fourth quadrant. So the angles in the first and the fourth quadrant that have a cosine value of 1/2, those angles are pi over 3 and 5 pi over 3. Now, if you want to put your answers in order, that's first quadrant, second quadrant, third quadrant, and fourth quadrant. You do not necessarily have to put them in order. You can leave them as you found them, or you can write them in quadrant order. All right, so in our second example, I am going to factor. So what I am going to do is I'm going to move this to the other side. You do not, whatever you do when you are solving these equations, you do not divide both sides by a trig function, because if you do, you will lose answers. So we're going to put everything on one side. So that's cotangent x minus cotangent x sine squared. I am limited from pi to 2 pi, so I cannot give any answers in first or second quadrant. I'm going to set that equation equal to 0. I'm going to factor out a cotangent x, which leaves me with the factor 1 minus sine square x. And then I'm going to solve. So my cotangent factor, I'm going to set it equal to 0. And then my 1 minus sine square factor, I'm going to set it equal to 0, and I'm going to solve it. So 1 equals to sine x, or sine square x. Take the square root of both sides. So sine x equals to positive and negative 1. Now, if you want to deal with cotangent, that's fine, or you can rewrite it as tangent x, and the reciprocal of that, which is 1 over 0, which is undefined. Now, there are 2 places on the unit circle where tangent is undefined, and that is 3 pi over 2 and pi over 2. But since pi over 2 is not in my interval for this problem, I can't use pi over 2. So my first value would be 3 pi over 2, because that is the angle within the interval I'm allowed that represents a spot where tangent is undefined. Now, sine x equals 2 plus minus 1. Well, for this particular problem, at pi, or 2 pi, that's 1, 0, and sine is 0 there. You've got negative 1, 0, and sine is 0 here, but at 3 pi over 2, you have 0, negative 1. This is the angle that I want. So I did all that work to come up with just one angle because I have to stay within my restricted interval, and I have to list the angles that represent these ratios, and that's the only one in that interval that has a sine value of either 1 or negative 1. Now, in number 3, I am going to take out the greatest common factor, tangent u. That leaves me with 3 tangent u minus the square root of 3 equaling to 0. So now I'm going to set these equal to 0. My factors equal to 0. So tangent u equals 0, and 3 tangent u minus the square root of 3 equals to 0. So that gives me 3 tangent u equals to the square root of 3, and tangent u equals to positive square root of 3 over 3. Now, when I am on my unit circle, I am limited from pi to 3 pi over 2. So I do not need to look in any of the other quadrants except for the ones that I'm restricted to. So tangent at 0, tangent is 0 at pi, because the ordered pair at pi is negative 1, 0. Tangent ratios, tangent at pi is y over x. That would be 0 over negative 1. So tangent at pi is negative 1. I'm sorry, it's not negative 1, it's 0. All right, so we have that one. And now I need to find in this quadrant, which tangent is positive in this quadrant, but I need to find the ratio for an angle in quadrant 3 that would give me radical 3 over 3. Well, that would be angle 7 pi over 6. So my two u values, if you go to angle 7 pi over 6, you place y over x, it will simplify down to square root of 3 over 3. So my two answers in quadrant 3 with respect to this question are pi and 7 pi over 6. In the next problem, we have a bunch of stuff going on. So I have to move this to the other side first. So that gives me sine x secant x plus square root 2 sine x equals to 0. I am restricted from 0 to pi, so I do not need to look in third or fourth quadrant because it doesn't fit my interval. So I subtracted 1 square root of 2 sine x and got 1 square root of 2 sine x. So I'm going to factor out the sine x, and that leaves me with secant x plus the square root of 2. I have it factored, so I'm going to set my factors equal to 0. And I'm going to solve each one. So I don't have to solve a sine x equals 0, but I do have to figure out where sine x is 0 in these two quadrants. That would be at 180 degrees, sine is 0, and also at 0. So I'm going to put those in order. At 0 and pi, both of those locations have a sine value, a y value of 0. Now, I need to work on this one. So secant x equals to negative square root of 2. I don't like secant, so I'm going to flip that and turn it into its reciprocal cosine because I am more familiar with cosines. So take negative square root of 2 and flip it. That will simplify to negative square root of 2 over 2. Now remember, you are limited to first and second quadrant, and cosine is negative in quadrant 2. So my x value, that relates to cosine x being negative square root of 2 over 2 in the second quadrant, is 3 pi over 4. So my answers are 0, 3 pi over 4, and pi for that particular problem. For number 11, we are going to, I do have a quadratic, so I am actually going to rewrite this problem. So I've got cosecant square theta. I'm going to add cosecant square to both sides. So I'm going to add that. I'm going to subtract 7, and that gives me negative 2 equals to 0. So basically what I'm factoring is x squared plus x minus 2. When I factor that, I get x plus 2 and x minus 1. Well, I'm not just factoring x, I'm actually factoring cosecant theta. So I'm going to take both of my x's out, and that's going to be cosecant theta plus 2, cosecant theta minus 1, and that equals to 0. I'm going to take both of my factors, set them equal to 0, and solve them. So this is cosecant theta equals to negative 2, and cosecant theta equals to positive 1. Now, if you don't want to deal with cosecants, you are well within your right to figure out where what angles are represented by cosecant equaling to negative 2 and cosecant theta equaling to positive 1. For me, it is easier to do the reciprocal. Cosecant's reciprocal is sine, so I'm going to take that. I'm going to find where sine theta is negative 1/2. That's easier for me to identify. And here, when you flip a 1, you get a 1. So I need to find where sine theta is equal to 1. I did the reciprocals to go from both of these cosecant statements to these sine statements. Now, my interval that I am restricted to, 3 pi over 2 to 2 pi. So I am not interested in anything coming out of the other 3 quadrants. Sine is negative 1/2 at the angle 11 pi over 6. All right, and cosecant or sine equaling to 1 in this quadrant does not exist, because here you have the point 1, 0, and here you have the point 0, negative 1. Sine has to be positive 1, and sine is not positive 1 at either one of those locations. So we ended up solving this problem, and one of our factors did not produce an answer. So we had one factor that produced an answer, and we had one that did not, and that is okay. Sometimes that will happen. So for number 12, we do have a quadratic we are going to factor. This quadratic would be the same as x squared plus 3x minus 2 equals to 0. When you factor that without the trig function in it, you get 2x minus 1 and x plus 2. So I'm going to take both of these factors, and I'm going to put my sine alpha back in. It's easier for me to factor with just the variables. Take the trig function out, factor what you see, and then put the trig function back. But if you want to do it with the trig functions initially, that's fine. So I'm going to take my 2 sine alpha factor, set it equal to 0. My sine alpha plus 2 factor, set it equal to 0. Here I have 2 sine alpha equals to 1. So I need to find where sine alpha is positive 1/2. Here, sine alpha equals to negative 2. This produces no solution because a sine or cosine ratio has to fall between -1 and +1, and -2 is outside of my sign limitation. Now, for sine being 1/2, positive sign, so I do not need third or fourth quadrant because sine is negative there. And I need the two values where sine is +1/2. So alpha, sine is +1/2 at pi/6 in quadrant 1 and 5 pi/6 in quadrant 2. The last two examples, we are still going to factor. So here I'm going to move these two terms to the other side. So that is going to be secant to the 4th x minus 5 secant squared plus 4. So what I am factoring is x to the 4th minus 5x squared plus 4. So that would be x squared minus 4 and x squared minus 1. So I'm going to put secant back in. So that's secant squared x minus 4 and secant squared x minus 1. I'm going to set both of those equal to 0. I'm going to solve each one. So that's secant squared x equals to 4. When you take the square root, you get secant x equals to plus minus 2. Here I get secant squared x equals to 1 and secant x equals to plus minus 1 when you take the square root of both sides. Now, I don't like having to find secant. I am more familiar with cosine. So what I'm going to do is I'm going to take both of these answers and I am going to flip them. And then I'm going to look for the cosine values. So the reciprocal here would be cosine x equals to plus minus 1/2. The reciprocal here, when you flip a 1, it stays a 1. So cosine x equals to plus minus 1. Now, I am limited from pi to 2 pi, so I need nothing out of the first or the second quadrant. So the cosine equaling to 1/2 values out of quadrant 3 and quadrant 4, we have cosine at 1/2 at 4 pi/3 in quadrant 3 and 5 pi/3 in quadrant 4. Cosine equaling to positive or -1 would be at pi and 2 pi. So my 4 answers are here. Last problem involves tangent. So I actually have 4 terms, so I'm going to have to do factor by grouping. So group these two together. That's tangent square y, and that gives me a tangent y plus 1. If I take out a -3 from the next group, that gives me a tangent y plus 1. And then I will put the tangent square y by the factor by grouping method. And then I will keep one of the tangent y plus 1s using the factor by grouping method. So I have my factors. I have tangent square y minus 3 equals to 0. I have tangent y plus 1 equals to 0. So tangent square y equals to 3. Tangent y equals to plus minus square root of 3. And here I have tangent y equals to -1. So when I go to my unit circle, I am going to consider my interval. My interval for this problem is 0 to pi, so I do not need anything outside of the first or the second quadrant. So remember, tangents are trickier to find because you actually have to do the y over x ratio to find out which one is tangent at square root 3/3. So in the first quadrant, that would be your pi/3 angle. In the second quadrant, that would be your 2 pi/3 angle. So both of these represent that tangent y equaling to positive and negative square root of 3. Tangent y equaling to negative 1/2 would be in the second quadrant at 3 pi over 4. And those would be the final answers for those values for tangent y equals plus minus square root 3 and tangent y equals negative 1. Now, if you have any questions, this is only part 1. We will be doing part 2 later in the week. So let me know if you have any questions or concerns.